Hello, Assalamualaikum. My name is Farah Nasyitah Esa. And my supervisor name is Dr. RAIKHAN. So today I will present on my progress report for this semester, which entitled Reduction of Free Fatty Acid in Search Palm Oil Using Glycolysis as Biodiesel Feedstock. Okay, so let me just give some brief of the study. So basically what we all know is biodiesel is commonly produced from vegetable oil as feedstock, but the problem is the feedstock is high in cost and somewhat unethical because basically we get from the vegetable oil, so they are edible. So therefore, we would like to come up for another alternative to replace this vegetable oil. So in this study, we want to take sludge palm oil that we collected from palm oil mill effluent. So basically, sludge palm oil is a low quality oil collected from palm oil mill. It is a good alternative because it is cheap and we can introduce the concept of waste to wealth, and it is also renewable since it came from the palm oil effluent. But then the drawback is the high FFA inside the palm oil, considering that it is a low quality of oil. So the FFA will cause the formation of soap that will be undesirable in biodiesel formation. So because of this low quality of oil, we want to improve the quality by higher up the free fatty acid. So therefore, we would do the pre-treatment by glycolysis process. The FFA for SPO basically like can go up to 80%, but then we have to reduce it to 3% or below. So basically we want to do glycolysis, which is adding glycerol at optimum condition to produce the glycerides. So when FFA decrease to become glyceride, then the treated SPO can be used as biodiesel feedstock by undergo transesterification. So basically this is how it is to undergo the glycolysis. So we add the glycerol to mix with the free fatty acid inside the oil, and then with the help of zinc oxide as the catalyst, it will produce glyceride. And then from here we would do transesterification by adding methanol to produce the biodiesel. And then glycerol is actually the byproduct for the biodiesel production. So for the problem statement that we can come out from what I have explained before. So first is the depletion of the petroleum due to high reliance as source of energy. Therefore, we would like to promote the utilization of biodiesel for our alternative for source of energy instead of petroleum. But then the utilization of vegetable oil for the feedstock, resulting in high cost of production. That is why biodiesel is not really favorable to become a major source of energy. Therefore, we want to come out for alternative, which is the SPO, but then the high amount of FFA is another problem that will affect low yield of biodiesel. Therefore, we would go for the glycolysis. Then, common method to reduce the FFA, usually we use, other studies use methanol, but then it says its drawbacks because we have to use many more excess of methanol to make it successful treating the SPO. So for the objectives, first is to determine the physical and characteristic of such palm oil. Why we do this is because we want to compare the feasibility for the SPO. We want to highlight the characteristic of SPO. Even though it is a low quality, it still have the characteristic and have the potential to become the alternative for vegetable oil to produce the biodiesel. And the second one is the major one is to investigate the effect of temperature to glycerol mole ratio and also the catalyst loading to the reduction of FFA in SPO using glycolysis. So basically, we want to know the optimal condition for this glycerol process to have the most efficient and the most lowest FFA that we can get from the SPO through the glycolysis. Therefore, we will undergo all these three parameters in three different value. And then the third one, after we treat the SPO and then we get the desirable FFA amount, then we will assess the feasibility of treated SPO as biodiesel feedstock by undergo the transesterification. So for our scope of study, so basically we take the waste, which is SPO that we collected in Kilang Sawit Bukit Bandi in Terengganu, that we collected from the wastewater treatment plant, which is for the POMI, and then the characterization of SPO to produce its feasibility. So the significant characterization, we would do the FFA, acid value, color, moisture content, fatty acid composition, functional group, and also triglyceride composition profile. And then we would do the esterification, that we will employ zinc oxide as heterogeneous catalyst. This is to speed up the reaction. And then consists of three significant parameters that affect the glycolysis process, like I said before. And then transesterification to produce the biodiesel. Okay, the first objective. So this is the example result for the chemical characteristic. This is the research methodology for objective 2, which is the experimental setup. Like this, we will heat up the mixture of the glycerol and the oil and the zinc oxide also, and the condenser is to make sure that hydrolysis will not occur. Thermometer is to monitor the temperature at desirable temperature. And then for every hour, we will do the FFA test by using titration method, by using sodium hydroxide. So once it goes pink, we will record the value and we will calculate the FFA using this calculation. So the third one, we would take the optimal result, the lowest FFA at optimum condition, and then we would go transesterification, which we will utilize methanol. So okay, so for the result, for the first objective, which is to determine the physical characteristic, so we have done all except for the triglyceride profile. The HPLC we still didn't manage to do because the constraint from the equipment. Okay, so this is the summary. So basically FFA for the SPO is quite high, which is 36%, which give us the expectation, which is high FFA that will interfere the production of biodiesel. Therefore, we have to reduce it. Acid value is 79%, which indicates the high level of deterioration of oil. Functional group from the FTIR, we got the ester NOH point, which is similar with CPO, that indicate that it is qualified to replace CPO or vegetable oil. And then the fatty acid composition, we get that the majority is palmitic acid, which is similar with CPO, but then they have the presence of C20, which is lignocellulosic, maybe due to the mesocarp fiber from the palm oil production. And then the moisture is 1.5%, which is quite high, probably due to the exposure to the milling, and within the glycolysis we have to reduce it to less than 1%. So the second objective, like I said before, the methodology. Okay, and then so for the second objective, the challenge for the semester. So after we thorough reading and refer to the previous study is only significant to do certain parameters to analyze its efficiency and its optimal condition. Therefore, the parameter will reduce to three values as it may deduce to significant hypothesis and discussion. For the mole ratio of alto-glycerol, we take 1:1 to analyze if there is no excess glycerol, 1 to 1.5 for 50% excess, and 1 to 2 for 100% excess. The temperature, we take these three. Why we don't take 240? Because it is too high for this process and it will obstruct the process. And the catalyst, we take 3. We eliminate 2% because the excess amount of catalyst is not significant, and also yeah. So for the result for the second objective, so okay, basically I take this parameter, which is 170 degrees C and 1 to 2 alto-glycerol ratio. So okay, so we can see here for different catalyst loading at 0.25, 0.5 and 1%. From 36%, we can see that it reduced significantly for these three catalyst loading. So basically the lowest is at 1% catalyst. It shows us that higher catalyst loading gives faster reaction time, and also show that the catalytic activity actually help in this process. So yeah, the lowest temperature, the lowest FFA for 3 catalyst loading at these parameters, which are 2%, 2.3%, and 2.6% FFA, which is lower than 3% that we want. And then the complete reaction is only 3 hours, which means that actually at second hour is actually already indicate the complete reaction, but then we just test at, because we test at third hour, the result is somewhat like the same constant, therefore we stop the reaction. And then we can say that FFA decreased as expected, show the success of glycerolysis. So okay, the next one I just take for 190 degree, which gives us a much lower final FFA percentage, which is 1.5% at 1% of catalyst wet loading. This is because higher temperature gives better result because of the higher kinetic energy. But then the reaction time is also 3 hours, which is quite low. Yeah, so from here we can say that this reaction happens, how the glycerol react with the fatty acid and produce triglyceride and water. And we can say that actually at this parameter is quite good. I mean, we only use 1% and the temperature is not that high, and the excess in 100% excess glycerol. Yeah. So for the final FFA result for all 3 parameters at all 3 values is depicted as like this table. So what we can conclude is that actually at 1:1 alto-glycerol ratio, the value is also good, considering that we still the initial FFA is 36%. But then by altering the excess of the glycerol to 50% and 100%, we can see that we can obtain up to 0.42% of FFA. I mean, this is the highest and the best one, but we get it at the highest excess, the highest temperature, and also the highest catalyst loading. So this means that all these parameters actually affect the FFA reduction, and it gives significant impact to the final FFA, because if we just take these parameters, we can get up to only 5%, which is actually not the optimum FFA percent for the biodiesel production, and but then we can obtain up to 0.42%, and this means that glycolysis is actually a good process because FFA can be reduced up to this, and is also by using other parameters we still manage to reduce the FFA. So for the third objective, so currently it's not much because I just do one time, only have produced one time of the biodiesel from the treated SPO. Still in progress. I still want to do more because I want to have more sample instead of one sample to run some tests to certify the production of biodiesel. So in conclusion, we can conclude that SPO has the potential to become the biodiesel feedstock due to its promising characteristic. Only we have to improve its quality by reducing the FFA. But then we expect that by reducing the FFA, other quality also will be improved. Temperature contributes strong influence to the reduction of glycolysis. High amount of catalyst does not necessarily give better result, and other amount is sufficient. However, higher amount of catalyst gives shorter reaction of time. The FF% is expected actually the FFA, I think the best one is 20 to 20. We cannot go higher than that as will interrupt the process. And we can say that excess of glycerol help in reducing the FFA efficiently. So for the Gantt chart, I expect that by March, no, by March, by April, I will done the FAME composition, which is the biodiesel characteristic, and I can do the thesis after that. So for the status, currently there is no publication yet. I'm still working on the paper review, which is expected to be published by next month, and the thesis writing is on the way. So for next semester, I still have to do the HPLC since objective 1 is still not done, and then I will get the objective 3 done by obtaining more biodiesel sample to run the lab test, and then I will get the review paper done and the thesis done. Thank you, that's all from me.